First of all, the disease, what we know about it. Secondly, how it proceeded and how we think it happened, kind of the timeline of events. And third thing is we're going to update you on some ongoing research that was started real quickly after in July. And so there's a lot of information that you guys, or questions that you may have, and I'd be glad to answer them. If you don't see it, hear it, or just raise your hand, interrupt me at any point in time, and we'll answer those questions. So feel free to, open discussion is what I want to have this morning, okay? So to begin real quickly, some background on the virus. PED is a coronavirus, so it is very much like TGE, and it was first identified way back in 1971 in England. At that point, they really looked like TGE. They thought it was TGE, but for some odd reason it was different. A few years later, they actually classified it as a new virus. All right. Since that time, it has spread through Europe and then mainly disappeared. Most of it, the last cases were actually in Italy, somewhere in about mid-2005, somewhere in there was the last time that really Europe had an issue with it. But since then, since England and Europe, it actually went to the Asian countries, and that's where it's been most devastating. So somewhere around 98, 99, or maybe 95, I think, in Japan, that PED showed up, and since that time has been spreading havoc in Asian countries, whether it's Korea, Taiwan, all those countries have endemic PED problems and are pretty severe. So that's kind of where we're taking a lot of our information from. The hard part about PED is that it is actually very difficult to propagate in cell culture. So there's not a whole lot of information. Meaning, if I have feces and I want to grow that virus up, it's very hard to grow. For an example, since the outbreak here in the U.S., there's been multiple universities and so forth trying to grow this virus. To my knowledge, of only one university at this point has actually got it to grow, and that's been Iowa State. So it's very difficult to actually have the virus to work with and to make new tests from. The other thing is, that's kind of a good thing for us, is there's actually only one known serotype. And what serotype means is that once you make antibodies to it, those antibodies should be protective or somewhat protective. If there's different serotypes, meaning different antibodies or different viruses make different antibodies and they're not cross-protective. So at this point in time, we do believe that PED, there's only one serotype to it. Most of the viruses, the PED virus that came from into the U.S., is very similar to the European isolates, which is very similar to the Asian isolates, meaning one virus. The U.S. isolate at this point in time that we've actually sequenced and looked at is 99.8% similar to a Chinese isolate that was put in the gene bank in 2012. Meaning they sequenced the whole length virus, and there's only a few mutations that would indicate this is a very, very stable and similar virus to what was reported in China. Are there any questions on that? So basically what I'm trying to tell you is there's one serotype, and our isolate that's in the U.S. right now is very similar to an isolate that was reported in China just last year. So how this virus works, it's a single-stranded RNA virus that's enveloped. The key thing right now is enveloped, which helps us actually destroy this virus a little bit more readily than other viruses. There's 7 open reading frames in this virus, which encode for 4 proteins. And these proteins are important when it comes to testing. We have a spike protein, we have a membrane protein, an envelope protein, and a nuclear protein. So you can make a PCR to these open reading frames. And it depends on what diagnostic lab you're in or where you're at. That's what you'll see kind of show up as the testing. Most people right now are probably using the N gene, the nuclear protein, because it is the most conserved portion of that virus. So I'm not sure on other diagnostic labs, I apologize, but at least at Iowa State, we're running as a normal routine the N gene, looking for this nuclear protein because it's the most highly conserved portion of the virus. So I know this is kind of confusing, but just wanted to show it so that you understand what we're looking for and testing for when it comes to this virus. Chris.
Darin, do we have any idea which of those proteins for protection is
The immunity? I think I have that in a slide, but yes, most of the time they're going to be to the spike protein because it's the longest one or head sticking out there is where the immunity comes from. The spike protein is going to help it attach to cells, and if we can neutralize that prior to hitting to a cell, then it won't usually be put in. So the spike protein's this long one coming out, and then you have a nuclear protein and a envelope protein kind of on here. The nuclear protein's on the inside. That's why it's the most conserved. So that's what we're usually testing for to make sure that we're actually correct. So antigenically, the spike protein and the membrane protein probably give you the most antigenic diversity. That's why those antibodies are important to those for protection. Transmission. Here's where it's going to get interesting. And I have some new information, but I kind of want to talk about that at the end. But if you have questions, we can go through it. This information is what I've pulled off of papers that have previously been published. All right. To our knowledge, this virus only infects swine. All right. With TGE, there's been instances of birds carrying the virus. Yes. Is that possible with PED? I would assume so, but I'm not definitive for you, because if they're walking on manure or feed that's, has manure on it and going from site to site, that's a potential fomite distribution of the virus. But infection-wise, it only appears that swine are the only species. It is a fecal-oral transmission, and typically outbreaks occur about 4 to 5 days after a pig movement, meaning if the movement is the source of the contamination, basically it takes a couple days to get rolling until you actually clinically see lots of pigs affected. People are wondering, I'm sure, there's been some talk, rumblings, at least that I've heard, about aerosol transmission. I know that some researchers are doing that. I think someone said that they did find it in aerosol outside of a barn. The infectivity of that, though, is unknown. I do know of another researcher that actually put pigs, he inoculated pigs with PED and then put a second pig or a couple pigs about 10 feet away in the same room, and has been monitoring them both. And after 21 days, the pigs that were 10 feet away have not gotten infected. So at least in a short distance-wise for aerosol, it doesn't appear to happen in a controlled setting. Now, could that be different in the field? Oh, heck yes. But the initial information would state that it's probably still a fecal-oral transmission. Pig-to-pig transmission, that's how it works, right? One pig shedding the feces, the other one pig picks it up. Supposedly, there's only a 7 to 9 day period of disease, meaning if I'm a pig and I get infected, I'm only supposed to shed that virus for 7 to 9 days. Well, we've kind of went past that by a long ways. So that's what all the research says, or literature states, is 7 to 9 days, but I'll give you some more information at the end that states that that's longer. We do know that there is no long-term carriers as well reported, but again, we're still doing some research. There's a lot of universities working together, trying to figure a lot of this stuff out. So thank them if you see them. So last thing is the biosecurity is probably the biggest risk, and I'm pretty sure that's kind of how the whole situation happened with trucks, and I'll explain that towards the end when we talk about the time frame of disease. But it's just like TG, right? We got to make sure we're cleaning trucks and our biosecurity is intact. If we're not washing market trucks and going back or going from the slaughter plant, we potentially are just carrying PED or TGE back to the next farm. So that's kind of the reason why it spread so fast. So quickly, at least in Iowa, we do know that the first 5 cases that we know of in Iowa were actually all connected by a trailer. That's a trailer or truck wash from that moving forward. So biosecurity, biosecurity, biosecurity seems to be the take-home point on this slide. All right, so what are the outcomes post-infection? There's 2 things that can happen. One, which we would all like to see, would be elimination. The bigger problem would be it becomes endemic, and then we don't see it because lactogenic immunity is protected to piglets, and therefore we probably break post-wean. We're all working towards not becoming endemic. And it's a very fine line between the eliminated and endemic, because you don't see clinical signs in either point until it's too late. With that, one big thing that I've learned in the last 3 months is that if you have a Selfharm break and the treatment is feedback, make sure you do it correctly and often to fully eliminate it. It's very important to get that feedback right, not just once. You may have to do it for multiple weeks in a row. I was actually talking with Hans Rado, who's been to Russia multiple times, and he deals with it there as well. And he says there's failures if they don't feed back a long enough time period. So we do have some reference from him, but also reference from you guys. I've had rebreaks. People call me on rebreaks because they didn't feed back long enough, or just once or twice, and they were hoping to eliminate it, which ends up being a major problem because about 6 to 7 weeks after the initial outbreak, they're still having diarrhea issues because of not potentially properly feeding back. All right, we're going to talk a little bit about the virus and why it's so devastating. The virus, oral transmission, oral fecal route, fecal oral, what happens is in the intestine, it will attack mature enterocytes. And the key word is mature enterocytes. All right, so go back to anatomy. You got villi, right? Enterocytes are lining your villi, and usually only the top portions of those villi are actually mature in a post-wean pig. And that's why you get diarrhea that way. It just kind of sheds those off, causes blunting and fusion of those villi. We get diarrhea. They usually survive. However, we'll make a distinction here in a little bit to neonates. There's cytoplasmic replication, and the time from infection to actual shedding is only about 12 to 18 hours. So it's fast. Gets in, gets out, and it's pretty devastating. The most severe diarrhea, potentially, is somewhere around 24 to 48 hours. Some people say 36, which is maximum effect. That's when the virus got in, and its first phase of dumping is occurring. Basically, what happens is the virus gets in the cell, replicates to this high amount in 12 to 18 hours, and then when it's released, that cell dies and causes the high shedding. Occasionally, we always think of it as small intestine, but occasionally there can be infection in the colon with PED. Doesn't really cause disease, so to say, but you can find it in colonocytes. So it's kind of it can harbor the virus as well. So here's your anatomy lesson, the cool part of the day. All right, this is a normal neonatal piglet. The villi are really long. The crypts are really short. So villi, these long things, made for absorption. Crypts are down here, really short. Somewhere around a 7-to-1 ratio is normal. All right, mental picture. Everybody got it? All right. This is a pig that was killed 18 hours after PED infection. So all the brown staining is immunohistochemistry, and that's PED antigen. Now, I told you before that in a post-wean pig, PED only affects mature enterocytes, and those are only at the tips of villi. Well, in a neonate, a pig that's just born, the entire villus is lined with mature enterocytes. Therefore, PED disease is much more severe in neonates because the virus has more cells that it can attach to and enter. So we saw that if we go back to the first slide and we see that truck full of dead neonatal piglets. Basically, we're somewhere between 80 to 100% mortality if your sow farm gets infected in neonatal piglets. Post-weaned pigs, yeah, there's 100% morbidity, but mortality is pretty low. And it all has to do with physiology of a neonatal pig and having the receptors for PED to actually enter those cells. So that's what you see 18 hours post-infection, and obviously that's going to be a lot of virus shedding in the environment. So if you can check right down here, so I told you these are all mature enterocytes, and just way down here is the only immature enterocytes. So it gives you a kind of a full effect of the massive amount of replication that's occurring in a neonatal pig. This is the end result. So we had really long ones. This is 24 hours. No shit. I'm not lying. I am not lying. 24 hours after infection, they are that short and they have fused. Like here's a crypt and here's a crypt. So you got 3 together into 1 in 24 hours. So basically whatever they're taking in has not even come close to being absorbed and just passing right through. The other part, the cool thing is this virus, what it's doing is attacking these enterocytes and they're dying and basically starting to kind of, this is a pathology thing, kind of die and kind of stretch out. And occasionally with this virus, you get multinucleated cells, which is unique to PED compared to TG or some other enteric viruses. So occasionally you get to see multinucleated or viral syncytial cells, which helps with the diagnosis. Here's our immunohistochemistry again. If you compare this one to the first one, this is the 24 hours, so all those cells that had the virus staining in it prior are now just a few because all those mature enterocytes died and were sloughed off. Any questions so far? All right. Here's where it's going to get interesting again. PED has not been detected outside the intestinal tract of pigs according to previous reports. All right, previous reports say that, well, it's just small intestine, occasionally colon, and that's it. Well, there's a lot of talk potentially about lung being a source, and I know that the University of Minnesota has been testing it and can find it, I believe. I'm not 100% certain on that. We're doing our research as well, looking for that. We just haven't ran the PCRs yet. So potential, let me back up. Coronaviruses, respiratory coronavirus of pigs is a mutated type of TGE thing that actually causes pneumonia. Bovine get a respiratory coronavirus as well, so that has the opportunity to attack epithelial cells on bronchi and bronchioles. So therefore, this coronavirus would potentially have the opportunity to infect some respiratory epithelial cells within the lung. To my knowledge, at this point, we haven't found it, but I think that the University of Minnesota is actually testing lung for it and has been had positive. So just keep that in mind. And we have found it in mesenteric lymph nodes. So I've done IHCs on samples that you have delivered to the lab or in our own research, and we do find it in lymph nodes. So at least we understand that it can be absorbed and taken back to a lymph node, potentially thereafter. There is the ability or the concern, maybe is a better word, that potentially it could go to other organs. But testing in progress is all I can say.
Are they finding it through PCR?
What's that?
Are they finding it through PCR or IHC, or how are they detecting it?
The question was, are they finding that virus by IHC or PCR? And the PCRs haven't been run yet. I found it by IHC on our samples. The University of Minnesota is running PCR on lung tissue, and that's where they're detecting some positives. But on a research aspect of all the research that's going on, I'm not sure many people have ran lung samples yet for the PCR. Sorry?
What are your thoughts
How much? Doesn't take much at all. We So the question is, if it does infect the lung, is it shed then, and is it infectious? Most likely would be yes, if it's possible. I wish I had better answers. Our PCRs are just not done yet to determine if it's there. We did take nasal swabs, and I don't want to infringe on another researcher's results, but I will tell you he's been taking nasal swabs, and they've been positive. And I'll just leave it at that, because I don't want to infringe on their work. But I do know that nasal swabs have been positive. Oral fluids, on the other hand, I can tell you about. Wickedly ass positive. I mean, if it's about the same as it is in feces, you'll find it in oral fluids. It's there. So it's a good sample that we find to actually test and probably monitor. Feces would be a little bit better just because we could detect it a little bit longer. But in an acute phase outbreak, oral fluids tracked feces for the first week, and we're only 3 to 4 CTs difference, with the oral fluids being 3 to 4 CTs higher than feces. So, for instance, if you have an acute outbreak of PED, we're typically getting feces in the CT range of anywhere from 9 to 12. Our oral fluids were anywhere from 15 to 19. So it tracks pretty good, at least for the first week. It's also been reported that PED is less severe than TGE, and pardon my French, but this is my BS flag, because it's just the same. It can be just as severe, even more devastating in a naive situation. So I'm just telling you what's been reported and trying to compare that to what we're seeing through the lab. So what you'll see is watery diarrhea. It smells, literally looks like TGE. Suckling pigs are most severely affected, as we talked about, because of the mature enterocytes. 100% morbidity in most cases, and greater than 50% usually. If mortality is just basically due to dehydration. The vomiting thing has come up multiple times. Do you need vomiting? No. Does it occur? Yes. How often does it occur? Probably. It's a pretty low percentage of pigs. From my experience, at least from the research facility, we had 100 pigs, and we maybe saw it in 5 pigs, and it was within the first 3 days is all. So, can you see it? Yes. Is it a prerequisite? No. So, look for it. It helps you with the diagnosis, but it's not necessarily essential. So, if you open a pig, this is what you'd see. I don't know if you can see it very well, but maybe you can pretend to see it. The entire small intestines are basically almost see-through. So you have those villi that were long that make it really thick, and then all of a sudden, when you saw those things off and make them really thin or really short, you can almost see through the intestines. So that's what you're kind of seeing here. Is you can see the liquid and everything through them. They're just almost paper thin. If you put your finger underneath them, you could see your fingerprint. That's how thin they get. Some of the properties that have been reported: it's pretty stable virus from 5 to 9 is all, and it can be heat inactivated at 60 C for 30 minutes, but is moderately stable at 50 C for 10 minutes, I believe was the quote. The good news about this virus that's saving us is it's an envelope virus. It's not like circovirus, which is non-enveloped. The enveloped property gives it increased susceptibility to killing and desiccation. So that's, at least we got that going for us, which is nice. Anybody get that from? Okay. All right. Sorry. Caddyshack. Anyway. So that's the nice part about this, is it's an envelope virus. What most people have been asking, though, what can we use to kill this virus? And because it's an enveloped, almost all disinfectants will work because it's an envelope virus. This is a paper from 2002 in Swine Health and Production, and it just states a couple of ones they had actually tested, Tectrol and bleach and some other ones. We know that Synergize will work too, and people are actually calling to run their samples on some cell culture. It's just we just don't have enough time in the day to get everything done. But at this point, it is our belief that most disinfectants, as long as they're applied properly and given the proper contact time, should kill this virus pretty readily. Questions on that? So the other thing is, it's because it's envelope virus, that heating and drying, the desiccation of the virus is great as well.
Do you think the desiccation is the bigger thing? If it looks like it's moderately stable with a fair amount of heat, is the desiccation a bigger piece of that?
Yep. If I had two options, if I just put it through a baker, if I just let it sit to make it perfectly dry, I would make it sit till it's perfectly dry. That appears to be the best option.
If you're using a truck baker and you bake it, you still got water left over.
Yeah. Yeah. If you're going to bake it, great, but make sure it's completely dry before you pull it out and use it. Very well. We're going to get into the story just so you know the history. You've probably heard multiple versions, but I'm going to tell you the Iowa State version. Here's the deal. So the first 6 cases are up there with the dates. April 29th, we have an Iowa sow farm that pigs walk in, should be TG. It smells like TG. It's devastating. We're all confident it's just TG, move on. Well, a day later, another sow farm submits samples with the exact same thing. And a week later, we're getting nursery barns that should be TGE, but we're not finding it. And then right after that, we get a couple sow farms in Indiana that have similar signs and disease compared to the first 2 cases a week previous. All those cases had severe diarrhea, some vomiting, and all are TGE negative. We sent samples to Minnesota, we sent samples to SDSU, we sent samples to Kansas State University, all within that first week going, for some odd reason, we're not detecting TGE, this should be TGE, help us out. And their results also come back all negative for TGE. So we kind of got a little bit scared there, and then give these samples to NBSL for electron microscopy and EMs. And as of May 10th, we do get all these fecal samples have coronavirus-like particles in them. And thereafter, NBSL, the National Veterinary Services Laboratory in Ames, Iowa, actually ran the PCR to determine its PED. So we knew on May 10th. We actually kept it a secret from you until the government, or until all the appropriate channels within the U.S. could be informed of what was happening, to do our due diligence, and then the announcement came out on May 17th. That's when everything changed. It's been a little hectic ever since then, but we've had fun doing it, and new challenge to determine what's going on here. So it's 2003, maybe it's 2013, typo, sorry about that. So with that, I just want to let you know where we're at. So we know that the first case, supposedly, that we had at the lab was the last day of April. We've gone back and we've done some testing of all the samples that were stored, and it appears that the first case that we can find that came through Iowa State was on April 15th. About 2 weeks prior to what we thought it was is when our actual first case came through. And that case was from Ohio. You get these updates weekly through the AASV if you're a member, and you can go to the website and see what's going on. This one is just Iowa State's, and has the states, and then by week the total number of samples or sites, premises that are positive that we've tested. Also, the National Animal Laboratory Disease Testing Laboratories have taken over the multi-state, multi-institution recording. And basically what they have total numbers across all diagnostic labs and so forth is right now is at 403 sites that are positive as of the week of 7/21. So they're always a week or two behind what's going on. You'll see multiple different diagnostic labs use different tests. Currently, at least Iowa State, we have 3 PCRs that we can possibly use. Most of the time we're using the N gene for the nuclear protein, the spike gene, and the nested PCR are just used as backups or confirmatory PCRs. We can test feces, intestines, oral fluids. We can test feed. And more recently, a lot of people have been doing investigations potentially of environment samples or trucks or lairdages or slaughter plants. And we can use the Swiffers. We have a modified Swiffer technique that we can test as well. The Swiffer technique was first reported by Pete Schneider and Daryl Holtkamp, I think, in 2010 at the AASV meeting, wherever that was. So we can test pretty much any sample you can think of. We can test it, and there's a little bit of difference of how we do it, but we can get it done. We also have an IHC that was developed shortly at the end of May. So we can do fixed samples to look for the virus. Problem is the IHC is not as sensitive as a PCR. And the other issue is we just haven't had time to go back and do a retrospective study to see if there's actually cases prior to April 15th that were actually positive. So that's kind of where we stand. One of the biggest issues, though, right now, or the bottlenecks in the testing, is serology, because that's going to be a huge thing to determine, our gilt's positive or so forth, and we're getting there. We're getting there. Because we've been able to grow the virus, at least Iowa State shortly will be offering an IFA test to determine if there's antibodies. So it'll give you a titer of 1 to 2, 1 to 10, 40, 80, 160, 320, that sort of reaction. Those should be coming online here shortly. Thereafter, we will probably have an SN test or serum neutralizing assay that follows. The ELISA test, the typical ELISA test, we won't have that for a little bit longer. That take a little bit more testing, rigorous testing to actually validate, to understand what the actual cutoffs would be with those. So I apologize for the not having an ELISA test, but we will have some sort of serology in the near future that we can test samples on. All right, the last couple slides here are just what we have going on at the lab and some hearsay maybe of what you have heard. So if you look at the timeline, the first case is Ohio, the actual second case is Indiana, and the third case is actually Iowa. And those cases all have a direct truck, as I said earlier, a direct truck/truck wash tie. So we know that it's very easily shipped and across the country pretty quickly, but the question is then, well, how did the Ohio case pop up? Is that the first case, first of all, is the first question. But even so, how did they get it? Well, multiple people believed or think that feed is a potential issue. We've tested a lot of feed samples. There's been a lot of question on that. NVSL actually put a positive feed sample into pigs that came from a southern state. That bioassay was never positive, but the PCR was positive. At Iowa State, we have tested numerous samples. We ended up with 2 questionable samples on feed. One is a vitamin premix, one is a plasma protein product. I think we've tested those things probably 15 to 20 times on all 3 different PCRs. And they keep coming up positive on 2, but the third one's always negative, and it changes sometimes. So at this point, I have no idea what to tell you. Do I think it's possible? Yes. But the issue comes then, it's an envelope virus, desiccation, and time being there. The question comes then, is it infective? And if I had a crystal ball, I could tell you, but I don't. Do I believe it's the source? If you're going to hold me to the fire, I'd probably say no, but maybe I will figure that out in the near future. I don't know. But potentially, feed could be a source, but the likelihood of that being the source is hard to manage or understand unless there was a major flaw in a manufacturing process. So I just kind of want to leave it there. There's a lot of questions in my mind about it, and I'm sure you guys have a lot more questions, but we honestly just don't know, and I apologize. We have been doing some research, as mentioned, and we're doing 2 studies right now. One's a weaned pig study and one's a neonatal study, and we're looking at this duration of shedding, oral fluid detection, lesions, and clinical signs. And what's interesting is the oral fluid data that I presented earlier is cool. We figured out that we can use that and be pretty realistic and catch it real quick, and it's a good sample. From the neonate portion of the study, on the right side of the screen, we had diarrhea really quickly. 24 hours post-inoculation, these pigs were depressed, anorexic, and shooting diarrhea. Severe diarrhea by 36, and basically from 48 hours on, pigs were just dying like flies. We were just doing everything we can to keep them alive to 72 hours to make sure the study was complete. I mean, we were giving fluids and all this stuff just so we could have the samples at 72 hours. But they are going to get so depressed and basically so lethargic that they just don't want to suckle, and basically that's why they die of dehydration. So you're lucky to get them past 48 hours post-infection. And the weaned pig study, the interesting part was it took a little bit longer than I thought to get it rolling. We inoculated, and it wasn't until about day 3 that finally the whole pens were squirting walls. There were still some holdout pigs for some odd reason. We didn't have very much vomiting, and it was usually a day behind when the diarrhea started. So out of 100 pigs, I think we had, like I said, 4 or 5 pigs that actually vomited that we could tell. Diarrhea is pretty severe from day 4 to 7. And the most interesting part of this whole dang thing was it stopped. It completely, at 100 pigs, all infected, it completely stopped the diarrhea at 8 days. No more diarrhea. Every pig looked, it was a complete turnaround from day 6 to day 8. I mean, they were just off the walls again, no diarrhea, and looking bloomy again. So that was the interesting part of it. However, the shedding data is so interesting that it's boggling my mind. We're only supposed to shed the virus for 7 to 9 days. Currently, we're on DPI. Yesterday was DPI 32, and we still have positives. Almost all pigs were still shedding at DPI 21, and then from DPI 21 to 28, we lost about 70% of them, and we still have a few pigs that are shedding at DPI 32. So that's the scary part. They look perfectly normal on DPI 8, but we're shedding. They were all still shedding for 14 days after that, and we still have a few pigs that are shedding beyond that. So even though the pig looks good, it could still be shedding that virus, is the moral of the story. They lost about 1 week, which makes sense. There was a 5-pound difference in weight from that first week. but after that, they're just tracked along with them. So basically you have a hit for 1 week and that's it when it comes to production parameters. Yep. At DPI 21, so the question was, the length of shedding is longer, so what's the CT value? And don't put too much stock into CT values, but what we've been seeing is from about DPI 21 to 28, we saw the CTs in the mid-20s kind of get to around a CT of 30. And then thereafter, last week, when most of them went positive or negative, we've had a few CTs in the low 30s, like 31, 32. So, and we're, like I said, as of last night when the results came in, there's still 2 pigs shedding on DPI 32. Oral fluids, first week is positive, second week's positive, third week's positive, and we haven't ran since then yet. So it appears that oral fluid tracks really well with what's going on. Yeah, so that's what you see. A lot of feces and a lot of thin-walled intestines. This is a weaned pig, 3 days. Again, they're almost see-through.